Hello viewers, today I came back to the field of welding and specifically for the electrodes. Do you know that why we need to coat bare electrodes? The iron can itself weld, why we need to coat it and spend more. But let us refresh our mind. When molten metal is exposed to air, it reacts with oxygen and nitrogen present in the air. As a result, metal oxides which are detrimental to the integrity and strength of the weld. Hence, it is required to protect the molten metal for oxidation. In covered electrodes, this protection is provided by the flux coating available on the electrode. The flux coating burns up due to the heat of the arc, and the gaseous product of this combustion envelop the arc physically, keeping out the atmospheric gases. Some of the products get mixed with the molten metal and deposit on the base metal surface. When the molten metal solidifies, these products float to the top and settle down there in the form of slag. This slag protects the steel hot metal from oxidation. The most basic function of flux covering is to protect the weld metal from atmospheric gases. Besides this, the flux also contains ingredients that stabilize the arc, influence the amount of spatter generated, influence the depth of penetration of the arc into the base metal, improve the rate of metal deposition, and sometimes even influence the chemistry of the weld metal. Further, the bead that emerges when the slag is removed has a uniform smooth appearance. Now, let us have some history how people realized or how the previous welding specialists who developed the necessity of bare electrode and how the idea has been started. Oscar Zellberg invented the world's first coated welding electrodes in 1904 by dipping a bare wire into a mixture of carbonates, including wood pulp or cellulose, and silicates as a binder. While advances in metallurgy, electrode coating composition and manufacturing technique continues to this day. The fundamental principle of shielded metal arc welding or SMAW in short, also commonly known as stick welding, remain. Global demand of SMAW and covered electrode. Just because a process is old doesn't mean it is not relevant. SMAW electrode account for about 20% of the filler metal market. Based on survey on 2017 on USA, the quantity of electrode consumed estimated about 150 million to 250 million pounds in North America alone. Split between low hydrogen and other types has remained relatively constant for last 5 years. So you can imagine what is the demand of SMAW welding process. The consistent demand of SMAW electrodes, and when it comes to the situations that require portability and simplicity, SMAW offers the most benefit. Before we go to more detail of types of coating, let us discuss about electrode nomenclature. Means, what is the science between naming an electrode? Let us take a popular example of a low hydrogen electrode, let's say E7018H4R. E means electrode. 70 represents the minimum strength, in this case a tensile strength greater than 70,000 psi. 1 is for the all position welding capabilities. 8 is the characteristics noted in figure 2, especially that it runs on AC or DC positive current. H4 is the diffusible hydrogen level. R is maximum of 0.4% moisture by weight after the exposure. That means the flux coating is guaranteed by the manufacturer that it will not contain more than 4% of moisture. AWS classification A5.1 explains it. E is for electrode. Next two digits will be the minimum ultimate tensile strength in KSI, which has to be multiplied by 1000 to get the pound per square inch or psi value. Then the next two digits for usability of electrode, AC or DC, means electrical characteristics, and the welding position. If it is 1, it is for all position, 2 is for flat and horizontal, and 3 is for flat only. H4 represents the diffusible hydrogen level, and R is for maximum 0.4% moisture that is allowed to present in the flux coating when it is opened from the manufacturer's packing. Utility of electrode coating. The electrode coating provides arc shielding when the calcium carbonate in the coating decomposes calcium oxide and carbon dioxide under arc heat. The primary source of slag system, which supports the weld paddle that helps to remove impurities from the molten metal weld deposit. Arc stability through elements such as sodium and potassium. A primary source of alloying and additional filler metal. Electrode coating, we can add some alloying elements which will be incorporated in the welding when the flux melts and mixed with the weld metal. So there is no wonder nowadays the strength of welding is sometimes more than the base metal strength. Here is a brief flow sheet for the cover electrode production, manufacturing process you can say. So the basic core wire or rod is prepared by wire drawing, and then it will cut into required length. Before we process with any electrode making things, all the core wire has to be checked with a chemical and physical analysis and checking. Then dimensional check will happen. After the cutting, the length and strengthening will be checked. Then it will go to the extruder. And on the other hand, raw materials of the flux are collected. There will be a quality check, of course, before it is accepted to use as a flux. Then the raw material will be turned to a dry blended powder. Then next step is wet mix check. After wet mix check, briquetting. Then it will also come to the extruder where the flux coating over the core wire will happen. After the flux coating has been applied, it will go for air drying, then baking. Then they will short the electrode, means how many per box will be there. In between, there will be a quality check like coating diameter, pressure, printing, stub ends, and striking ends. After the shorting, the welding performance will be checked for using sample from the lots. Weld metal will also be checked. Finally, if it pass all the quality checks, it will be go for packing, storage, and then mechanical test. So a lot of quality checks and carefully selected procedure, a electrode is being prepared. But still there is a chance of malfunctioning because of simple wrong storage, either by the manufacturer facility or during the transportation or simply by the contractor who is using this. So not only the good manufacturing process can decide the quality of an electrode, but it continuous proper storage and handling will finally give us a sound weld. Now let us discuss how many types of coating for SMAW electrodes are there. So now let us discuss how many types of welding electrode coating for carbon steel electrodes. You can see the electrode designation E6010. The type of coating and current is the last digit, which is 6010. 0 is the last digit. From here you can see a table in AWSA 5.1 what are the types of coating. Let's say 6010, the types of coating is high cellulose sodium, which can be used for DC positive. 1 is for high cellulose potassium, AC and DC plus minus, anything it can be used. 2 is for high titania sodium for all types of current except DC positive. If it is 3, it is high titania potassium. It is for all types of welding current, let's say AC, DC positive and negative. Iron powder is 4, titania. It is also for all types of welding currents. Low hydrogen sodium is 5. If it is 6015, then you understand 5 is for low hydrogen sodium. So it is only suitable for DC positive. Low hydrogen potassium 6 is suitable for AC and DC positive. 7 is for high iron oxide with added iron powder. So it will contribute more iron to the weld. It is suitable for AC, DC positive and negative. Same with number 8, low hydrogen potassium with iron powder. It is suitable for all types of welding current. So you can see the types of welding coating. Let us discuss the major headings or major types of the electrode coating. The core wire is an SMAW electrode, can be a solid drawn rod, a cast material or a fabricated core wire. The core wire conducts electric current to the arc to melt the base metal and provides the filler metal for the welding joint. If we want to weld mild steel or low alloy steels, the typical core wire grades are carbon steel only. Whereas if we want to weld stainless steel, then the core wire will be like 304L, 308L, 309L or 316L as required. Many specialty wires also are available, including aluminum and those for built up and hard facing. These electrodes have a core wire composition that complements the coating and electrode design for the classification and application. There are three primary types of electrodes: cellulose, rutile and basic. Basic is also termed as low hydrogen electrode. Obtain their name from the coating type. Electrode coatings that help optimize performance for various applications by influencing how quickly the slag freezes, penetration, deep, medium or mild, and deposition rate. The coating also contributes the good arc initiation, easy rest strikes, puddle control, and a stable arc with minimal spatter. So first one is cellulosic coating. This coating on a cellulosic electrode contains up to 30% or more wood flour. The coating is relatively 12 to 15% of the electrode diameter and produces a thin, easily removable, fast freezing slag suitable for all position welding, including vertical up and vertical down. Cellulosic electrode provide a digging or driving arc with deep penetration. The weld puddle, wets and sprayed weld demonstrate excellent mechanical properties and has distinctive ripples. Cellulosic electrode include E6010, E7010 and E6011, which are typically used for pipe, barges, form repairs and maintenance work, and also even dirty plate. With cellulosic electrode, we have 4 to 6% moisture in their coating compared to 0.4% in E7018H4R. Too little moisture might prevent the coating from producing adequate shielding gas and result in poor performance. Store EXX10 and EXX11 at room temperature in an airtight container. Rutile electrodes like EXX12, 13, 14 and 24 should be stored at 100 to 150 degree Fahrenheit. The cellulosic electrode can be cellulosic sodium based, EXX10, for example 6010, 7010, with cellulosic material in the form of wood flour or reprocessed low alloy electrodes up to 30% paper. The gas shielding contains carbon dioxide and hydrogen, which are reducing agents. The gases tend to produce a digging arc that provide deep penetration. So, it is often used for pipeline, especially for the root. Cellulosic potassium based, which is XX11, that is 6011, let's say 7011. These electrodes is very similar to the cellulose sodium electrode, except more potassium is used than sodium. Our second type is rutile electrode. Rutile is a mineral composed primarily of titanium dioxide. Rutile electrodes such as E6013, 7014 and XXX16 class stainless steel electrode offer a soft arc with lighter penetration than cellulosic electrode. The slag is electrically controlled and arc ignites and restrikes easily, offering greater welder appeal. They typically are used in general fabrication application where mechanical properties for critical weldments are not required. Some examples of rutile iron powder EXXX4, very similar to the rutile coating mentioned above, except that iron powder is added. If iron content is 25 to 40%, the deposition rate is increased based on the amount of the iron powder in the coating. Rutile sodium based XX12 with rutile or titanium dioxide content is relatively high with respect to other components, provides a fairly high rate of deposition. When the rutile is potassium based, example is EXX13, this electrode coating is very similar to the rutile sodium type, except that potassium is used to provide arc ionization. The third one and most important, which gives us a most quality weld and strong weld, which is basic electrodes. It is offer an arc with medium penetration and excellent mechanical properties. The coating is low hydrogen iron powder, titanium oxide, calcium carbonate and calcium fluoride. The coating is of medium thickness and adding of iron powder increases deposition. It freezes relatively fast to enable flat, horizontal, vertical up and overhead welding. Basic electrodes such as E7018 are used for critical welds in structural steel construction, bridges, ships and offshore oil and gas applications where mechanical properties are important. Another important benefit of basic coated electrode is good resistance to crack formation. Basic coated electrode allow welding in all dimensional positions, mainly with direct current DC positive. With additional alloying, these electrodes can be used for welding of high strength steel, heat resistant steels and facing welding work. Drawbacks or some deficiencies of basic coated electrodes are low workability, sensitivity to porosity formation, special requirement of packing, storage, transportation and preparing for welding, sensitivity of contamination, difficulties with AC current. Maintaining a basic electrode sometimes feels impracticable. So, color and content for coating for SMAW electrode. Electrode color is mostly cosmetic and often results from oxides that become part of the slag system. Don't select an electrode by its color. Confirm the AWS classification and or electrode name by looking at the printing of the coating. For the curious, if you want to know, the colors signify the following. Red is for iron oxide, green is for chrome oxide, white color electrodes contain titanium oxide, blue cobalt oxide, tan color because of zinc ferrite and iron oxide on the flux coating. So guys, that's all for today. Hope you have an overview that why we need a coating on the bare electrode, what are the types of coating we have and some very basic know-how of electrode manufacturing. Hope this information will help you to increase your knowledge. Please be with me if you really like it. Please share and subscribe. Signing off, Showman.